Hey everybody, let's spend a little bit of time talking about Lewis symbols, which is kind of the precursor to talking about Lewis dot structures. But before we get into the symbols, let's do some definitions. So we're going to get into talking about bonds, and there are three types of bonds in chemistry. Okay, there are ionic bonds, which happen when electrons get transferred. It's a transfer of electrons. Let me make sure I do this. Okay, it's a transfer of electrons. And so, for example, what you end up having is sodium becomes an ion. Sorry, I'm moving stuff out of my way. And so sodium becomes an ion, and chloride becomes an ion. And this happens because sodium loses an electron and gives it to chlorine. And now this is a positive, and this is a negative, and opposites attract. And that becomes the attractive force that holds those two things together. That is what an ionic bond is. Okay, a covalent bond is when atoms share electrons. And so one example is between carbon and hydrogen. You have one electron and carbon has an electron, and they create a 2-electron bond here where these 2 electrons are around hydrogen, and then these 2 electrons are also around carbon, and they share this. And so what this is this is an overlapping of the electron orbitals, okay, atomic orbital overlapping. So it's, remember SPs, Ds, and Fs. Okay, well, wherever those electrons are that are overlapping, that's what we end up getting. Okay, and the third type of bonding is a metallic bond. And so if we have metal nuclei, okay, these little dots symbolize nuclei, that means what can happen is the electrons can float around anywhere they want within what they call a matrix of the metal. And so that's why metals can conduct electricity, and that's one reason why they're malleable. Like this metallic bonding is pretty special. Okay, in order to do Lewis structures or Lewis symbols may deal with ionic, but definitely all the covalent bonds. Metallic bonds we don't really worry about too much. Okay, and so, but in order to draw a Lewis symbol, again, precursor to Lewis dot structure, we need to be able to count valence electrons. And I'm going to take this because for some reason it's on the wrong thing. But so here we're going to count valence electrons, and remember that neon represents the core electrons, and then anything beyond the core is are the valence electrons. And typically we say they're the electrons in the outermost energy levels. And so that means that sulfur has 6 valence electrons. Okay? And so in order to do this, what I'm going to do is I'm going to put 6 electrons around sulfur. And what we do is we kind of imagine sulfur is in a box. Okay? It's not really in a box, but imagine. Okay, and that box can hold 2 electrons on each side. But we're not going to put 2 electrons on each side to start with because, remember, Hund's rule says that electrons don't want to pair unless they have to. Okay, so we're going to put 1 electron in each side until we get 4 electrons. And typically, we should probably do it in some order all the time. So I always go top, bottom, right, left. Okay. That's 4 electrons. Now we're going to pair the other 2. So now we have 2 pairs and 2 non-paired electrons. Okay, so that's a total of 6 electrons. So this is the Lewis symbol of sulfur. Okay, what we don't want to do is we don't want to go 1, 2, 3, 4, 5, 6, where it's not clear what's paired and what's not. Okay, that's a no-no. Okay, and I guess this relates back up here. As we're counting valence electrons, let's ignore any D's and F electrons that we deal with. So something like bromine has an electron configuration of argon, and then it's 4s2, 3d10, 4p5. And so the definition of valence electrons is the outermost energy level. So the outermost energy level is 4 and 4, so that's 7 valence electrons. Okay, and so we do that we do that like that. Okay, so let's practice this. Okay, so sodium has 1 valence electron. Okay, so we're going to draw its Lewis symbol. We're going to put 1 dot right there. Okay, and now for bromine has 7 valence electrons. We just went over that. So 1, 2, 3, 4, 5, 6, 7. Okay, so that's 7 valence electrons. Oxygen has 6. 1, 2, 3, 4, 5, 6. Okay. Tin has 4 valence electrons. 1, 2, 3, 4. Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. Bismuth, 1, 2, 3, 4, 5. Bismuth has 5 as well. Okay, so notice anything that's in the same family will have the same Lewis symbol. Okay, so we will eventually talk about the octet rule, but that's the Lewis symbol, and yeah, there we go. Have a great day.